Okay, at this point we have gone over basic algebra. We've looked at how to solve linear equations. We've done rational equations, radical equations, absolute value equations. We've now looked at quadratic equations. We've seen when we get real solutions, when we get complex solutions. So basically, any linear or quadratic equation I give you, even some that are not quadratic but are quadratic in type, you guys can algebraically manipulate and solve using all the different tricks we've gone over. And now there's kind of a natural progression in math, the way we do this stuff. We start by learning all the algebraic tricks to solve things, and then once we understand how to solve them, then we look at applications, word problems, to see how this stuff works in the real world. So that's what we're going to do here, and I'm actually going to use a few problems from your book so that you guys, rather than trying to scribble out everything that's written on the board and I can pause the video and do all that, can just look at your book and copy things right out of your book or follow along in your book so that you don't have to waste a lot of time trying to write down everything I write down. The one thing I will say before we start though, here essentially you guys have probably used a lot of the things we're going to go over today in other math classes that you've done and for other applications you've done. We're just going to kind of make them more advanced now. Meaning, all of you, I'm assuming, have seen the simple interest formula. I equals PRT. Interest equals principal times rate times time. We're going to use that to solve problems, but you will never get a problem in this class like find the interest if the principal is 1,000 and the rate's 2% and time is 2 years. We're going to do something a little bit more advanced than that. By the same token, probably from physics or something like that, you may have seen the formula D equals RT. Distance equals rate times time. If I drive my car 50 miles per hour for 2 hours, I go 100 miles. But again, we are not going to solve problems just using that. We're going to use that in a larger context for bigger problems, so just be aware of that. We're going to start with the interest ones, and I will also stress these applications can take a while just to solve out correctly. So this might take multiple videos just so you guys have several examples worked out of these applications. So to start with, we're going to look at page 89, number 5 in your book. And if you're there, I'll read this just in your book. Rocco borrowed a total of $5,000 from 2 student loans. One loan charged 3% simple interest and the other charged 2.5% simple interest, both payable after graduation. If the interest he owed after 1 year was $132.50, determine the amount of principal for each loan. So first off, as an application, you need to know what you're looking for. And in this case, it says find the amount of principal for each loan, which means you're looking for 2 quantities. Mathematically, there are different ways to do this. One way is to say, if I'm looking for 2 quantities, I'll just let x equal the first number and y equal the second number. I'll have 2 variables because I'm looking for 2 quantities and I'll be good. Problem is, mathematically, if I have 2 variables, I need 2 equations, which makes my work harder, and we haven't actually covered how to solve systems of equations yet. So we don't want to do that, so we're going to try to solve these with only 1 variable. And when you're going to do that in math, generally you have to find a way to relate both of the quantities that you're looking for in terms of that 1 variable. So for the purposes of this, let's see. Rocco borrowed a total of $5,000 from 2 student loans. One loan charged 3% simple interest and the other 2.5% simple interest. So let's see, just because it's first, I'm going to say x equals the amount borrowed, the principal, from the 3% account. There's no reason for that beyond the fact that it's first in your book. It doesn't matter. But now I need to find a way to write the amount of money he borrowed from the second account in terms of that x. And this is kind of a standard setup for these, but it can be a little bit confusing the first time you see it. We're told he borrowed a total of $5,000. And if you think about it, if he borrowed $5,000 total, if I told you the first account he borrowed $1,000 from, you would immediately know the second account was $4,000. Because 5,000 minus 1,000 is 4,000. If I told you he borrowed 3,000 from the first account, you would immediately say he borrowed $2,000 from the second account, because 5,000 minus 3,000 is 2,000. Since we know he borrowed X dollars from the first account, how much did he borrow from the second? Do the exact same thing. Here I did the total minus 1,000, the total minus 3,000. So this is the total minus X, because that's the amount from the first account. That's how much is in the second account. The total minus the amount in the first account. So now I have a way to relate the quantities, and that's my second variable. 5,000 minus X is the amount from the 2.5% account. Now I have the two variables that I need to solve the problem. I just need to come up with an equation now that I can actually solve. And in this case, we are told the interest he owed after 1 year was $132.50. So my total interest from both accounts was $132.50. But where does the interest come from? Well, the interest comes from the first account and the second account. And that tells me my equation right there. In order to get my total interest, I need to find the interest from this account and the interest from this account. But how do I get interest? We use I equals PRT. So now let's see. From the first account, my interest is principal times rate times time. The principal from the first account is X. The rate from the first account is 3%, which all of you know means it has to be written as a decimal, 0.03. Time, well, for this problem, we're told the interest after 1 year, which means time is just 1, and I don't have to worry about it. And I will actually point out, as far as the way these problems are worded sometimes, occasionally you won't be told time on the problem. If you're not told time, just assume time is equal to 1, and you'll be fine. But now, that's the interest from the first account, principal times rate times time, which is 1. The interest from the second account is the principal, 5,000 minus X, times the rate, 0.025, times time, which is again 1. I know my total interest is $132.50. And how are they related? The interest from the first account plus the interest from the second account has to equal the total interest from both accounts. And now I have a nice equation that I can actually solve. So just solve it for X. 0.03X plus, just distribute, and here I'll even pull up my calculator, 0.025 times 5,000 equals 125. So I get plus 125 minus 0.025x equals 132.50. 0.03x minus 0.025x is 0.005x equals, subtract the 125 over, 132.50 minus 125 should be 750 if my quick arithmetic is correct. And now to get x, divide 750 by 0.005. So we get 750 divided by 0.005 equals 1,500. If we did it right, that should be the amount borrowed from the first account, which I guess is the 3% account. I need to find the amount from the second account, but that's 5,000 minus X. 5,000 minus 1,500 is 3,500. So it's 3,500 from the 2.5% account. And there we go. There are the two quantities that I'm looking for. One other thing that I would actually point out as far as this goes, while it is not true in the real world, the problems in your book and on Alex are pretty idealized, which means if I set up all this algebra and have all these decimals and solve the whole thing out and get nice round numbers, more than likely I did it correct. You can check this by actually plugging into my equation and making sure it works. It will in this case. But if you're solving these out and you get something like x equals $3,284.12, in the real world, that's a possible answer. For the purposes of the problems you're solving in this book, that would probably be an indication that you did it wrong. And you should go back and check your setup, check your equation in your algebra, because you probably did something wrong. So just kind of use that as a tip when solving these. you should get reasonably round number answers. Like I said, we want to look at a couple other applications, but given the length of this video already, I'm just going to make another video going over a different type of application.